All right, problem 1-73. Consider circles of different sizes. Create multiple representations of the function, an input-output table, an equation, and a graph, with inputs that are the radius of the circle and outputs that are its area. First things first, area. We have, for a circle I should say, is going to be pi times the radius squared. So this is the function that we're going to be using. Our input is going to be r, and that's our radius. And our output is going to be our area, and obviously that is A. So we want to do a table, an equation, and a graph. Well, right now, here is our equation right off the bat. This is the function for area. If you wanted to use x's and y's, then you could do that. You could say then that y is going to equal pi times x squared. So this would be another form of it. If this helps you with setting up your graph in your table, think about it as your input and outputs. So as I take it here and I want to set up a table, I'm going to draw a little input-output table. And that looks good. We've got our input, which is our radius, and our output, which is our area. So if I'm going to start out here, obviously, if we're thinking about the domain being our input values, we're not going to have inputs that are negatives. That wouldn't make any sense. We can't have that negative distance. So I'm going to go ahead and just start with 0. And even this is considered to be a debatable value, whether or not it is included in the domain. Because if I take 0 and I plug it into the function here, I'd get y is equal to pi times 0 squared. And obviously 0 squared is 0. And when I multiply that by pi, it's still going to give me 0. So I'm going to have a 0 right here. When I increase my radius to 1 unit, I plug it in there, I'm going to have y is going to equal pi times 1 squared, which is going to equal, well, 1 times 1 is 1, and times pi is going to give me just pi. So I'm going to go ahead and list pi there. That, remember, is approximately 3.14. That's important, though, for when we're going through and putting our graph together. Let's do a few more values. Let's go 2, let's go 3, and let's go 4. So the next one, we take 2 and we plug it in. We're going to have y is going to equal pi times 2 squared. So 2 squared is 4. 4 times pi is 4 pi. Three, we plug it in there. We've got 3 equals pi times 3 squared. Well, 3 squared is 9. 9 times pi is going to give us 9 pi. And the last one, 4, we take it and we plug it in there just because I'm following the pattern here. We have 1, we have 4. 4 is 2 squared. 9 is 3 squared. So 4, we're going to end up with 16 pi. So the next part here is just about taking this and setting up a graph. I'm going to sketch one in here. I don't have a coordinate plane ready, so I apologize for that, but let's just do a nice little sketch. Okay, now my input values are my independent variable. Remember, that always goes on the x-axis here. So that is going to be our radius length. So I'm going to add that in down here. We've got radius. And units right now, it's not really going to matter because we're not really dealing with a specific unit. And then over here, we're going to have our area. Our y-axis is going to be represented by our area. So We're going to put 0 down here, and let's think about it here as we go. We dealt with 0, 1, 2, 3, 4, so we could add in there 0. We have 1. We have 2. We've got 3. We've got 4. I'll just add a couple more on there just for fun, I guess. Math is fun. All right, so, and on this side here, if we think about it, okay, this is approximately 3.14. 4 times 3.14, if you think about it, well, 4 times 3 is 12, so you know it's going to be a little bit greater than 12. 9 times 3.14, well, 9 times 3 is 27, so think about how high it's going to be getting. And then 4, here when we plug it in, we ended up with 16. 16 times pi is going to be about what? It's going to be at least 48, probably, more than that. So, that kind of can help you set up what your values are going to be, what your scale is here. So let's do this. Let's go by tens. That'll work. So let's do 10, 20, 30, 40, and 50. So we do have that restriction on our domain because we can't go back in the negatives, and we also have the restriction on our range, our output values, because we're not going to have negative areas. So we're dealing mainly with quadrant 1 here. So when we plug in 1, we get pi out. So I'm going to say that's probably going to be somewhere down here. Oh, I'm sorry. Let's put in our point down here at 0. Some people think that should be an open circle. Some people say closed. I'll leave that up for debate. So 1, we're going to be about a third of the way to 10. So about 3.14. So we're about right here. When we go 2, we just said that it's going to be approximate. These aren't exact here. We're trying to make it look as best we can. So if we did 4 times 3.14, we said it's going to be at least 12, so we're going to be going up 10, 12, somewhere about right in here would be good. And then when we do 3, we said 9 times 3 was 27, so you can multiply times the 0.14 as well if you wanted to, but you know that it's going to be more than 27, so we'll be up here. Let's go about here. Looks good. And then when we do 4, we have 16 times 3 is 48, like we said earlier, and then it's going to be more than that, so we're going to be up here. Now, will that one make it to 50? Let's double check that and see. So we can be a little bit more accurate with that one there. Let's just pull out your calculator and do 16. And then we can multiply it by our pi, which if you do second, pi is located right over here by the caret. 16 pi is about 50.26. So we don't want to leave it under 50. We want to make sure it's a little above there. So let's take it here. Thank you, Mr. Calculator. Let's go back and let's do 4. So it's going to be just a little above 50 here. And you'll notice the shape that we're getting here should look like about half of a parabola. Ooh, this pad's really hard to draw this with. Hopefully yours is a little bit smoother than mine. That's going to go up, and we want to include the arrow on the end because that function is going to continue up that way. So we've put an input-output table right here. We've got an equation for our function here, and we've got a graph here with inputs that are the radius and outputs of the area for our circle there. If you have questions, make sure you ask your teacher. Thanks for listening. I hope this helped you out there. This is Mr. Boyd signing off.